Hello, everyone. My name is Dinorah Tovar. I'm Google Developer Expert on Android, also mobile, sometimes when I'm not fighting with the Gradle files. Uh, I work in a Mexican company, which is called Confio. And when the build of the Gradle is not stuck, I usually post memes on my Twitter account, so you can follow me there. So today we're going to be talking about life cycles, and it's a quite long talk. So I will start getting started. Especially on Android, there is always something with a life cycle at the end of the day. And what does it mean? Well, usually your general application has a life cycle, right? Your activity, your fragments, and even your classes, you can even make aware of the life cycle. Where are they? How they are going? How is everything working? So most of the times, you depend of that life cycle. But first, I want to give you a little bit of context. Because when we talk about life cycle, we also are talking about multiple variables and multiple classes that are running on an Android application. Usually, there is two things I want to speak about it. There are thousands. Okay, I'm just not going to go deeper on it, but these two little guys, the life cycle and the life cycle owner, are quite important. Because the lifecycle, yes, that's the name of the class, has something called state and events, and we are going to be talking about a lot of them today. And then we have the lifecycle owner that has multiple functions, multiple variables, but we are just going to be focusing on these three little guys, because if not, this talk will last 2 weeks. So we are going to start doing that. For example, the states are stages in a graph. You probably already see them. They are destroyed, initialized, created, resumed, started. They are the moment on the time when something happens on the life cycle. But look at the names. They are destroyed, initialized. It's not on pause or on resume. They are different names. Because the stages are processing this in the time. There is something else that we call it the edges between these stages. When you have an edge, you go from one edge to another edge. You have to go over a state, okay? And these events are probably the ones that you already know. On create, on started, on resumed, on destroyed. All of these events are triggered when you go to the edge of that stage, okay? Who hasn't heard about these little guys? I think everybody, right? Awesome. Okay, so there is something else about the life cycle owners, and the life cycle owners pretty much, when we talk about them, we are talking about the fragment. I know not everybody likes fragment, but if you are using a fragment, the fragments and the activities and the dialogues and things like that, okay? So you have fragments, and usually you ended up initializing a life cycle. And when you start initializing this life cycle, you initialize the life cycle registry that will handle all the transactions you are going to have in your activity or your fragment. You also have a view tree lifecycle owner. Yes, the ones that reports everything that is going on in your activity or your fragment. A view model store owner, that if you are using a view model, this is the little guy that is in charge to remove that when it's no longer in use. And you have a save stage strategy that it will handle all the bundles and things like that when you go to on stop, on resume, and you recreate the fragment or of the activity. Because the lifecycle registry, the first one we were seeing, is actually handling all the observers. It's the one that add the observer to the view, so you can keep tracking of all the things that are happening in your activity. For example, we're going to see a little bit about live data and how this is actually used. So be my guest, just bear with me a little bit. And when you are talking about the on lifecycle event, it's actually this function. It doesn't do a lot. It's actually just an interface that goes to the value and gives you the chance to obtain the lifecycle available at the given moment of your activity or your fragment. And we also have this huge class that is called View3 Lifecycle Owner. That what it actually does is that gives you the chance to set and get the lifecycle owner available at the moment. Remember, if you are using a fragment and you go from one fragment to another fragment, the lifecycle owner change. Because when you are doing this, your first fragment gets on the top of your second fragment gets on the top of your first fragment. And when it changes, this lifecycle owner is going to be the one in charge of all the observables that you are addressing at that given moment. If you have any Stateflow, SharedFlow, or live data that is addressed on your second fragment, that second fragment is going to be in charge of observe and do the changes on your view, right? And second, we are going to talk about, this is where it gets interesting, okay? That was just the little abbreviation about the life cycle and how it works. The second part is that we are going to talk about live data and flows. I know, you probably are no longer using live data. Does everybody still using live data? Kinda. Well, it's quite irregular, right? Just amuse me. This is important. Live data and flows works quite different. They have two different approaches, and depending on what we want to do, we want to use a live data or a flow. That's why Google is still saying that it's not deprecated. So usually, when you are using a live data, you have this type of flow, right? You have a view model, the variable that is your live data, and you observe, and you give the chance to this observer to have this, which is your life cycle owner, and then you have a lambda expression when you are going to do something with the result of that live data, right? And pretty much what it does is that the live data use the owner to address that changes and observe that changes and remove itself when it's ready to stop being using. For example, this is the code of the function observe. Yes, it's small. Yes, it's short and sweet. We're going to see what is going on, okay? So in the first part, you're going to see that you have a main thread annotation because live data only runs on the main thread. They don't run anywhere else. And even after that annotation, you also have an assert of the main thread. So we even check twice that everything is running on that main thread. After that, you want to check where are you standing in the life cycle of your fragment or your activity. You need to check that your life cycle is not getting destroyed. If it's getting destroyed, we don't add that live data to the observers. We don't say, hey, here is a live data that you need to be observing, and then I'm going to be destroyed. That's not how it works. We need to make sure that we are not going over this destroyed process to try to catch every change that we want to have in that observe. And after that, we go, we pretty much, what is going on in here is that M observers is, I don't remember, it's a static hash map or something like that, and just add that observer. Make sure that you can add it. That's what is going on in here. And after that, what is going on is that we make sure that that observer hasn't been added before. That's why it's so important that you only add these observers of your live data once. You make sure that you add it once, that's it. Once you are going over on destroy, you can just remove it, and everything is going to be really cool. And the last line, it's it's the one that is really cool, right? Because you use the owner, so that's your fragment or your activity. You get the life cycle that you already know that is not getting is not getting destroyed, and you add this live data to make sure that is part of your life cycle, and that will that will make the activity and the fragment know that everything that is going to be added is going to be in the correct state, in the correct given moment of your life cycle, and that is going to be able to be dismissed once the time is right. That's really important. Because, to be honest, live data works really well. I know it's not everybody thinks that way, but live data works really cool. But at the end of the day, this is highly bound to the main thread. There's no concept of what is a suspend function that doesn't exist in a live data. And it's also attached to Android. And you probably remember there was a version of the paging library or even Room has this option to have live data, but you ended up using a component that was solemnly pure of Android in your repositories, in your data sources. You ended up bringing something that was only focused for Android to the bottom of your application. If you were yesterday on the tag of Kotlin multi-platform, you know that maybe is not the approach you want to follow, because you ended up attaching all your code base to that specific component that is highly bound, super highly bound to Android. And at the end of the day, you ended up needing an activity, and a fragment, a dialog for every type of collection. So this is when the things get interesting, right? A lot of people were start using flows when flows was released to Kotlin, because flows at the end of the day give you the chance to do something very similar of what live data was doing. So a lot of persons were doing something like this. They were creating an observable. They were creating a scope based on the lifecycle scope. They were launching, and then they were collecting inside that flow. And that was really cool. But at the end of the day, the flows use a different form on observation. This is not the right approach. Actually, it's a very dangerous approach. Please don't use it. I know I put it on the slide, but don't use it. Because flows has something that makes it very complex for your UI. You cannot get a value of a flow. And your flows are not aware of your life cycle. And this is quite important. If you don't have the chance to have awareness of your life cycle, your mobile application might be ended on pause, on resume, on destroy, on stop it. You get a phone call and you are still emitting information to your view, even if you are not using your application, right? This is the big problem of the flows. When flows might be addressing a huge problem of the architectural side of the things and making the flows as something that you want to use around your mobile application, from your data repositories, from your network repositories, going for your entities, doing mappers, do whatever flow you want, and try to push that to your view models, and that goes to your views. That's quite simple with flows. But you need to be very careful how you are addressing these kind of problems, because you might be ended up getting born. Plus, there are many types of flows, many types of flows, and this will create many types of incidents. I put incidentes in Spanish, but it's incidents, sorry. Because you usually have two types. You might be exposing a SharedFlow and a Stateflow. And both of these are hot flows. And I want you to see the characteristics. The SharedFlow is the dad of the Stateflow, because the Stateflow is only a SharedFlow that it has a read-only state. But you have this characteristic of both of them, that they exist without collectors and emits to all the collectors. So if you have this change, this situation, you ended up doing something like this in your collection, right? When you are creating a variable in your view model, you might end up doing this. You create a variable, which is mutable state flow of some type, and you set up a value, right? This is quite common. Everybody has been doing this. Maybe not the mutable state of part, but the state of flow, yeah, maybe you are doing it. This is a variable that probably exists in the view models that we have in our mobile applications, like right now. I'm pretty sure you probably have some type of line that resembles this type of code. But in the activity, you ended up doing something like this. You do a private function, you observe that function, you create, again, the lifecycle scope, and you create this scope when you can launch and collect a flow. However, you ended up, it ended up looking something like this, right? And we might be thinking, maybe because this is a lifecycle scope and we are using .launch, maybe this is awareness of the life cycle, right? And we can collect the flow just like it's nothing, like it's not a hot flow and that can get burned. But, well, it's kind of, this approach is also not correct. I'm sorry. It's also not correct. Because what is going on is that this doesn't work for buffer, conflate, float, or shard in. You are using this on your view models. Probably this is not the best approach of the things. Because what is going to happen in here, and I know you are going to see this code and you are going to think about the coroutines when we start doing coroutines on Android. What is going to happen in here is that you are going to have to create a job at the top of your activity or your fragment. And then you are going to make sure that every time you go over the edge of the resume stage, you get that job attached to the collection of your view. And then when you go on stop, because on stop is going to move you on pause or maybe on destroy, you want to cancel that job. This approach was happening before on the view models when we were doing coroutines on the first set of when we were start doing Kotlin, right? Imagine you have to do this in all your views. It's insane. It's insane. It's a lot of code. And I'm not even joking. This is the right approach. It's also the right approach that Google offers. So if you're using Launch when it started, you have to do this because Launch when it started is not lifecycle aware. Launch when it started, Launch when resumed, Launch when created is only a function that gives you the chance to have a lifecycle scope that is created when you are on the edge of your lifecycle. Yes, this was the official documentation, guys. That was a long time ago, but if you go to the second line, I don't know if you see my cursor, but it says that as the view goes to the background, the underlying producers remain active. So if you go on pause, you go on stop, you get a phone call. If you change from your mobile application to another application and you are still emitting things to your view, this is a waste of resources. You are wasting resources of your phone, of your user's phone, and you are just degrading your views. But there is a solution. There is a solution. Not everything is bad. So you already see the problem of using SharedFlow and Stateflow when we are doing consumption of the flows in our views. And I just want to do a little animation in here. Imagine you have a flow, and you have this view. The flow is emitting constantly. And your view is just a view that lives in a moment on a specific process of your user life cycle. So when your activity is resumed, everything is going fine. You are just emitting, and everything is cool. Everything is going to be arriving to your view. Your view is going to start changing based on the information you have on the flow, and everything is it's magnificent. This is the perfect dream. But the things about your application is probably that your user moves a lot. So when your activity goes to stop it, your view is gone. And once your view is gone and your flow remains active, you end up not having nothing to be collected. And the flow is gonna keep emitting for the end of the time. So the problem begins when you are still emitting data to your collectors when there is no view. They don't care. They are only listening. So there is something we need to do with the flows if we want to use it. We need to have a way to launch and run all the flows we have in some specific stage. So if you are in a specific stage that I was telling you in before, you have events, you go from one event to another event. This process of walking from one event to another event is the stage part. You want that. You want to have a flow that can be launched and run in some specific cases, in some specific scenarios, and you want to cancel them when it's no longer on the stage. So if you go on destroy, on pause, you just cancel it, and you're ready to go. And obviously, you want to have an automatic relaunch and cancellation. There's a way to do it. There is a library that you can use. I believe if you update constantly your Lifecycle KTS library, you're going to find it. It's called Repeat on Lifecycle and Flow with Lifecycle. We are going to see in this talk what is going on inside of it, because it's quite big. But now that you have seen what is going on with the live data, you're going to see it, and you are going to think it's the same. Or pretty much not the same, but it looks quite similar. So what is going to happen in here is that you still have to use your lifecycle scope.launch to make sure you are able to run a flow. But inside of this, you are going to use your lifecycle, and you are going to attach your collection to some specific stage in your chart. You are going to use it, for example, in this case, when it's started. We want to start collecting as soon as we start the application. After that, we can do a view model.collect, and we can safely collect inside of here without the problem of trying to emit something that is not going to be addressed on the view, or something that we don't want to be collected. What is happening inside Repeat on Lifecycle? A lot of things. But especially what you are going to see is that there is no annotation or assertion for the main thread, because flows understand what is the concept of suspension. So what you're going to see is that you are going to get, the first line is that you're going to use a variable that is a state, that is going to show you the state, the moment your application is living at that moment, when you want to collect that information. And you're going to have a coroutine scope that is pretty much that, a coroutine scope. We are going to check where is the state, and that this state is not initialized, because it's quite dangerous to do it in that stage. So we wait a little bit. After that, we also check that it's not on destroy it, because on destroy it is that you are dying. So we don't want that. And the thing gets start interesting because you start using the coroutine scope, and you move everything to the main thread. And what is going to happen in here is that you are going to create a job and event observer. Inside of this, you are going to start seeing what is the event you are going to trigger after the stage you are starting the flow. That's happening in here. A start work event, val, start work event is equal to lifecycle event up to some specific state. The state, this little function lives inside lifecycle. There are some enums and some very specific classes that it's pretty much a state map change. If you are on resume, the next state that we are expecting is for you to go to a stop. If you go from one to this, you go to destroy, and that's pretty much what is happening on these two variables in here. After that, we make sure that the event is not a cancel worker. It's not on that specific stage that will go to a cancellation. So if you start your life cycle, your repeat on life cycle function with on pause, the next stage is part of these cancellation events, and you are no longer invited to the party to attach your observer. And finally, what is going to happen in here is that you are going to add the observer to your lifecycle event observer. This function is also a function on your live data. And if everything goes wrong, because everything can happen in the funny world of flows in live data, in lifecycle owners, you can also remove the observer if there is a crash on that try and catch, right? So that's what happened inside repeat on lifecycle. Making it complex, but this makes the trick because it will address when your activity is getting relaunched, and automatically it will push the observers again, and we make sure that everything is running fine. If you are going over on destroy, it will remove all the observers, and you are also fine. So that's really cool. This blog code is you can find it on your Android Studios. It's already there. And if you wanna go and look at all the documentation about this function, I think it's very cool. So what it will happen is that you can now use this function, except that you need to make sure that you are always addressing view lifecycle owner when you are trying to use your lifecycle scope. I know it's way big. I don't like it. It's enormous. You see, you ended up using your view lifecycle owner, and then you view lifecycle scope just to make sure you can able to use this function. But this will make sure that you are collecting safely. So in Mexico, we say unas por otras, which means sometimes you have to let go some things for other things. And then you can collect. This is the correct approach. And I'm going to be really honest why. This is the correct approach in a fragment. If you are using an activity, you don't have to use view lifecycle owner, because the view lifecycle owner of an activity is an activity. It's the activity itself. So it's this.lifecycle scope.launch. And there is another one, another friend, which is called Flow with Lifecycle. Flow with Lifecycle has a specific use case, because you are going to end up using something like this, that you probably, it looks the same that the first one we saw. You send this and view lifecycle.state the stage you want to start collecting. Looks the same, except that this little guy, this little friend, use a callback flow. So inside of this callback flow, you will end up using repeat on life cycle with some specific stage, and you will be able to collect inside of the stage. In callback flow, it's quite different because it's a call flow. So what it does very much is do a transformation of how you are trying to address the changes on your view based on what type of flow you want to do. A call flow very much gives you a chance to use other type of procedures and things like that. So That's the only difference of these little two guys. And last, and I promise this is the last one, Compose. And the state of collect as a state. Compose has also all the composable functions has his own life cycle. There is recomposition. There is the process of emitting the data to the functions. Usually what Compose does is that emit the changes to the view, right? Sorry. In a lot of person are using collect as a state to address all the changes that happen on your composable views. And it's fine, but it's also not so fine. It is what it is, guys. It's complex using flows. Because what is happening inside of this part is that in this little view, when you have a flow, you also want to understand what is the lifecycle owner inside your local lifecycle owner, inside your composable function. And inside of this, you also want to just remember the flow and remember which is the stage of your life cycle. So you ended up using remember, putting that lambda function that we usually use, and you ended up using flow with life cycle to change it to a call flow. And then you can collect that flow using collect as a state. This is too much. I think it's quite big because a lot of persons are only using the collect as a state. They are just emitting information like that. But the problem is that composable views has the same issue that the regular views has. If you have a view and everything is on resume and you are pushing information to your flow and your view is taking that and doing the changes, everything is fine. But if you are using it on Compose, it's something quite the same, except that you will not be able to pretty much stop using resources when you move. And that's awful, right? Because you might end up triggering another recomposition, triggering some side effects. Maybe you ended up like missing some things in your life cycle. And again, collect as state in this form has the same problems that the view and the XMLs and the regular other functions that you probably are using. But a couple of days ago, if you follow Manuel Vivo or Ian Lake on Twitter, you might notice they push a new version of lifecycle.ktx library. This library has another way to collect as a state using the life cycle. I haven't had the chance to figure out what is going on inside that library, what is different of this, and why it's so cool, and why we should be using that part specifically. But they are doing something like this. So now you can collect your flow using viewModel.yourFlow.collect as a state with life cycle. And this will make sure that your life cycle is in a specific stage that you want to be collected, that is on resume. When your activity is on track, that your user is seeing what is going on in there, and that collect as a state with life cycle will also remove the collector of the flow when you are no longer using it. So this will also make sure that you are not wasting any resources that you might want to use for another recomposition or another thing, like writing a file of everything else that happened in a mobile application, right? So this is probably the correct approach. I invite you to, all of you, start using the right process to collect any type of flow that you are consuming in your mobile application. Activities and fragments has a different life cycle. They are pretty much events and stages. that work as a node and work as a state machine. So please be very careful how you are doing it. It's quite cool, to be honest. It makes you realize that you might be using so much memory on when you are on pause and you don't know why. This is probably it. But give it a look. It's a proper way to check that everything is going great. I also have a blog post, a serial blog post about all these topics that is on my blog that you can find it online on my Medium account. So this is all. My name is Dinorah Tovar. This was Lifecycle for Android developers, and thank you so much.